All right, now we're going to do a problem. I'm not sure you can see all this, but I'm going to try to make it work. I'm going to do problem number 18. Now, hopefully you can read that over here because I didn't want to try to draw this picture, but this is what the problem says. The problem says, two ropes seen in figure 918, this figure, are used to lower a 255 kilogram piano 5 meters from a second story window to the ground. How much work is done by each of the three forces? They have already done a free body diagram for us, but we want to have our free body diagram here. So we got gravity going down, mg. We have tension coming off this way, they call it T2, and it is at 1,295 newtons. Then we have another tension coming off this way, it is 1,830 newtons. And we have that this angle here is 60 degrees, and this angle here is 45 degrees. And what we want to find is how much work is done by each force. All right, you should go do this problem yourself first, okay? And then come back and watch the rest of the video. So stop the video now, go do the problem, and then come back and watch the rest of the video, see if you get the same answer I do. All right, so this is how I'm going to do it. We know that there's a distance. Notice that which way it moves matters, and it's being lowered. So our displacement vector is 5 meters, and it's in a downward direction. We also know the mass of the piano here is 255 kilograms. Okay. So now I want to do the work by each of these forces. This is T1, T2, and gravity. Different than when we did the forces. When we did the forces before, we were going to do the net force and then figure it out. I want to do the work for each force. So for T1, I'm going to use this equation. I'm going to use this equation a lot. FD cosine theta. Okay. Now, the work done, so I'm going to call this work by T1. So I'm going to put a little subscript down here. The force, we know, is the tension, so this is just 1,830. Okay? And the distance it moves is 5 meters. All right, now what we got to be careful is the angle here. It's going to be the cosine of the angle, but what's the angle? Well, when it's moving this way, remember it's motion this way, the angle is actually going to be this whole thing right here. It is not 60 degrees. It's always between the force and the direction it's moving. Don't get caught up with coordinates. Coordinates don't matter anymore. So that is actually 150 degrees, 90 plus 60. So this is cosine of 150 degrees. Now what I know is, if the cosine of 150 degrees, anything cosine over 90 is going to be a negative value, which is what we want because it's moving this way and our force is going that way. So when we solve for that, we get the work done by T1 is minus 7,920 joules. And work and energy are both in joules. Now we're going to do the same thing for T2. For T2, the work done by T2 is equal to FD cosine theta. And the force in this case is 1,295 newtons. The distance is still 5, but now the angle is going to be this angle over here, or the cosine of 135 degrees. 90 plus 45. When I do get, I get the work total, work done by T2, is equal to minus 4,580 joules. Okay, again it's going to be negative because that angle is bigger than 90. Notice I don't ever put the negative in here. I let the angle take care of that for me. Don't put negative in because then the negative from the angle will cancel out. Just make sure that your angle takes care of that. And then the work done by gravity, there's going to be work, which is just going to be mg, the force of gravity. The distance is 5, right? Or mgh in this case. So the work is just going to be m, which our mass, let's put the numbers in, 255 times 9.8 times 5. Okay? And which direction is it? Well, the cosine of 0, this would be the force times the distance times the cosine of the angle, right? But it's moving this way, gravity's going that way, so the angle is 0. Cosine of 0 is just equal to 1. Okay? So the work done by gravity is going to be positive, and it is 12,500 joules. All right, now remember this one, in this problem, the piano is being lowered at a constant velocity. It's not speeding up, it's not slowing down. So the change in kinetic energy is equal to 0 because the final velocity is equal to the initial velocity, which means the net work has to be equal to 0. So if I sum up these works, they should equal 0. So let's see, we should have minus 7,920, minus 4,580, and plus 12,500. And if you add those all up, you should get 0, because there was no change in velocity of the system. What that says is that the work done is conserved, or the energy done is conserved. That's how you do problem 18. Okay? All right. Now, for yourself, you should do problem 18. Also do problem 43 and problem 45. And I will add videos showing you the answers for those, but you don't gain anything if you don't do them yourself. So do problems 43 and 45. This is in chapter 9.